Hello again. Let me know if you see me well, if you hear me well. Okay. How's the quality? How's the sound? How is life? Okay. I'll start over for the full video for the completion's sake. So the topic of today is operators overloading, and we're gonna talk about how to implement various operators on complex objects. And here are the operators that we know. We can add, subtract, multiply, divide, casting, compare, equality. Those are all operators that we already know. Uh, Except what happens if you add two people together? That's very much based on the context, on the person. It's really up to the domain the addition happens. And therefore, since it's so much dependent on the point of view, it doesn't happen often. Operators overloading happens not that often um, because complex objects are not obvious how the addition happens or any other operator interaction, because you need to guess. However, or all operators, like if you do need to implement operator overload yourself, uh, you need to follow the following structure. Operator is just a method. Um, a method which is named after the operator and it has the keyword operator. So when you want to overload an operator, all you have to do is to say operator for this operator and then just continue as if it was a normal method. How do you implement a specific operator? For example, subtraction. Operators do not have interfaces. Actually, no, they do not have interfaces, and you will answer why they do not have interfaces. Why do operators cannot have interfaces? And the answer is in front of you. Can you answer? Yes. Um, Interface cannot have static methods. Every operator method, every overloaded operator starts with static. Public, private, it depends. It can be private operator, doesn't matter much, but it has to be implemented. Um, Actually, I think it can be implemented everywhere. It doesn't have to be implemented in the containing class, though most likely it will be. If you want to do a generic sum, then you have uh, do generic operators work? I don't know. Maybe. We'll see. I think they probably do. So we can play around that during live coding part. So that will be extremely weird looking, but we'll see. Anyways, here we have an operator for subtracting one money to another. And as you can see, money is a simple data structure, which has an amount and currency. Because that's what money is. Like, you know how much of what currency there is. And being so simple, it's just a value object. Value object, it means that it's immutable, that it's almost like a primitive, but also has logic inside it. What logic does this money object have? It has logic for subtraction. It has logic for inverting money, turning into negative. And since um, and since turning into negative is basically creating a new money object with amount for the money made negative, and since it's that convenient to make it a minus operator, just minus, what is minus? You just invert the money, the value that it has. So you can literally just call that method to negative for money negation. And what is subtraction? Subtraction is adding the negative amount. If you add negative amount, you have subtraction. Actually, plus the sum operator is addition operator is implemented here as well, but I do not show it because it's a more complex one. Yeah, as you can see, to negative simply multiplies amount from -1. So whatever it was, it becomes inverted. Maybe to negative is bad. It should be invert. Yeah, it should be invert probably. To negative feels like it always makes it negative regardless of being negative already. All right, let's continue. Yeah, it should be invert. Okay, continue. Next example, what if we wanted an operator for comparing something? Again, if we check the structure of operators, static, return type, operator, keyword, and then operator itself. And for this one, static, return type, operator, operator itself. It always follows the same keyword. If we go back, we can see that the same operator had a single argument or 2 arguments. I'm not sure if it can have 3 arguments, but it's just a method. How do you compare two fruits? For comparing fruits, it probably depends on what matters the most. In this context, we have name and weight. Maybe you want to sort fruits by their name. Maybe you want to sort fruits by their weight. And to me, weight matters more. The heavier the fruit, the better. Brings more value. Therefore, if I compare fruits, I take their weight as a property for comparison. And really, it's very often that operator overloading will be just one line of code. So with this, I can literally say create two fruits and compare them without explicitly calling weight from the outside. And that's what makes it neat and cleaner. But whatever you can do with operator, you can do without it as well. It's just a delegation of logic. It goes slightly elsewhere. And that's a good thing though, when you think about it. If you can manage object from within itself, if you can have methods for that object within that object, you should. That's the clean design rule for object-oriented, domain-driven design. And again, we have equality check. How do we implement equality operator? We say static, type, operator keyword, operator itself. And then parameters, just like a method, the same. How do we compare people? Well, it just has a name. So we just compare per person by name. If names match, it's the same person, let's say. Of course, logic might be much more complex than that, but that's just for showcasing the operator. And in fact, you can even implement casting with operator overloading. So here we say, again, the same thing, except since you have implicit and explicit, it's a bit different. So the syntax is this: static, implicit, meaning that you automatically convert it. Operator is the same. Decimal is the same, like what you return. So this reads, if I assign money to decimal, I will get amount of that money object. And this is implicit cast. Implicit cast means that here you see, if I say decimal amount equals money, and if money was a money object, it'll take the amount immediately. Yes, it can be used for Unity programming as well. Since Unity is C# based, all that you see in this bootcamp applies to Unity as well. If you have implicit, do you need explicit? No, it's not mandatory. However, if you have equality, not equal is mandatory. If you have comparison, less is also mandatory. But if you have implicit, explicit is optional. Why is it optional? Because simply money could be decimal, money could be double, money could be float, even int if you really want to. It's up to you and it doesn't have to be mirrored. Why do you need implicit altogether? Well, because if I assign money as decimal, it's probably obvious that it takes an amount. But if I say that I cast a decimal to money, what does that even mean? And the meaning is that it basically creates a money object with undefined currency, which kind of makes sense. Like, if I have just some amount, and if I cast that amount to money, I don't know what currency it is for, so I just say it's undefined currency. What's the benefit of this as opposed to just treating that 15.0 M decimal as decimal? Well, now I have all the logic that money object has, so I can work with different money objects and not decimals. That's the benefit. The difference between explicit and implicit cast is that implicit cast, I don't cast, I just directly assign to something. And for explicit cast, I need to cast myself using those brackets. What else? And when you implement, you use implicit or explicit keyword. That's the main difference. What gets returned, it's up to you completely. It can be money, it might not be money, and the context that I'm at does not dictate what is a parameter and what is a return value. It's absolutely up to you to have different things in there. So when should you do operators overloading? To me, it's pretty much only when you have value objects. And that is a rare case, and especially a rare case for a beginner. And personally, at work or in my personal projects, I don't really use it. So this lesson is not especially useful. It could be extremely useful, but in most cases it will be not so useful, as it is quite a niche way of using operators. But it's nice to be aware. Now let's play around with it in live coding part. But first, do you have any questions? And if you can, I would appreciate if you could write one thing that you think you understood very well and one thing that you would like to know more, better. And I'll be right back in a minute. I'm back. Aurora said, from what I've just read, the type conversion can be added on either of the types you want to convert between. Yes. One thing that I should mention and that we'll witness in live coding part for explicit and implicit cast, implicit cast takes precedence. If you do have implicit cast, and if a method accepts both something that can be resolved using implicit cast and explicit cast, implicit cast takes precedence. So in this case, if my method takes both money and decimal, if my method takes both money and object, object cast is always explicit. Therefore, it will take double instead of object, as double was implicit and object was explicit. What question wasn't answered? Which one? Which original question? The only one I see is if you need explicit when you have implicit. You don't need explicit if you have implicit. And there were no other questions afterwards. Okay. Will it use implicit if you don't declare an explicit but cast it explicitly? Will it use implicit if you don't declare an explicit but cast it explicitly? I am not sure. I would say it would use implicit, but it's a guess. So we can try it out. Casting is here. Let's see the demo. First, the overview. We have an enum called currency, which has a bunch of currencies, and struct money, which takes amount and currency and builds money out of that. And then money has a bunch of operators. We will have more attention to plus operator. It's more interesting. The rest already you've seen. And now the question, if we delete explicit operator, and if we say that we want money to be taken explicitly. So we say decimal for that money. And I think, I'm pretty sure, yeah, it should. 15. Yeah, it does use implicit, and says it's redundant because it already does that. Okay, let's move on. Let's start from the more interesting method, which is addition operator. Yeah, that's what we do. If we add different currencies, it throws an error. Yeah. I am on the same page as you. And then we just add the amounts if it's matching and take the same currency. Alternatively, we could make the second currency as first, convert it, but this is too much logic for the money. uh, data structure, especially since money wouldn't be able to do currency conversion. Currency conversion is dynamic, it's constantly changing, and it needs a service to get that info. Um, I think it's irrelevant. I think it does make sense. Well, it doesn't have to be a simple operation because you're dealing with complex objects. Do you have any other example where you would um, be using non-primitive for addition? I think it's just because you all this time have been dealing with primitives when adding, multiplying, or subtracting. I think it makes sense. There's nothing inherently wrong with this, as it is just a method. It's just the method invoked slightly differently, and plus operation on complex objects shouldn't be expected to be a simple operation. It can be a complex operation. And I think the beauty of this code is that there is a lot of reuse. For example, addition, as we saw, is reusing this whole method, also this method, and basically the only difference is those two operators. So it makes code neat. And the operators, as you saw. Now, my question to you, though, it's probably a hard question, too hard for you guys at this stage. But if I delete this, what do you what do you think will be printed? As a hint, let's do a console write line, and let's see the overloads. So console write line takes bool value, char value, decimal value, and many more. And if you print this one, will this be printed? That's my thoughts as well, and I was a bit surprised when I saw a result that was different than the expected. In fact, if you look at money, you would expect that it prints amount and currency, but here you see it printed just the amount. And if you hover over it, you can still see that it kind of should print both, but it printed just this. Why is that? And actually, the answer is wrong. It doesn't print the string in this case. Why doesn't it print the string? It prints overload to currency, that is correct, the cast, because if we want to print this as the string, we need to do this. And then you see it gets printed as a string, as a string. But what is this as opposed to what we do with decimal? What's the difference between this kind of assignment and this kind of assignment? Or rather, this kind of assignment. It casts to decimal because the cast is implicit, and it doesn't cast to object because it's explicit. And it needs a cast in order to use the string method, because every object has that method. But this object comes from object class, and struct is a primitive, essentially, and it doesn't have a reference, so it needs to be casted to an object in order to get that the string method called. Therefore, it was printed just 20 because it was implicitly casted. Takes precedence. For the string to be called, money needs to be explicitly cast to object undefined. Also, something trivial, but just to be sure, what if it only had explicit overload and you cast it implicitly? It wouldn't work. And this actually is an example of many data structures. Actually, let me think. Confusion. Yes, so for example, you cannot cast integer to decimal. Or the other way around. Yeah, you cannot cast integer to decimal. And if you hover over it, it says cannot implicitly convert. Implicitly convert. So if explicit exists, you cannot convert implicitly. Like implicit is both if explicit doesn't exist. But implicit is only implicit. So implicit takes over explicit. So explicit takes over implicit when cast explicitly. But you can cast explicitly with implicit as well. And the opposite works. The opposite will work because we already tested. So if I remove this one and leave explicit, you can see here that nothing happens. You see, it says you cannot implicitly convert. So basically, that's what is for int under the hood. Okay. Next. So that's the demo for this one. You can see money, like we demonstrated how money gets added. We added 10 euros and 15 euros together, and we got 25 euros in total. And we then subtracted 10 euros from 15 euros, and that is minus 5 euros altogether. And lastly, the interesting thing about this, for printing it, we could even go for really fancy logic. Like, based on the currency, we could format it to that culture's currency. So maybe let's do that to make a point of this data structure. Okay. Text. Yeah, we will use a switch. So we switch currency. And we say if currency is if it's this, always forget the syntax for returning it immediately. But anyways, it would be, no, you don't need case because it will be just one liner. Basically it will be amount, the string, and we pass new culture info, and it will be like this. For GBP. Actually, we can return immediately. Let's do something like this, and I hope that my resharper will react. I am a bit lazy to Google. Okay, Visual Studio. No, that's not what I want. Switch section, braces. Okay. Let me Google up. I don't remember. Pattern matching, C#. No, no. Nope. 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 This is the one. Okay. What was it? Var switch currency switch. If it's this, then we return that. Right, discard. Oh, no, not quite. This is for pattern matching. Like this, okay. Case is not needed, that's correct. Okay, thanks. Good. Let's add it like this. Probably culture would be cleaner. Like this. Or even a dictionary. But we started, so let's continue. Currency member and the anom using the same name. Yes, it is. but it understands from the context what I expect. Okay. GBP, Euro, undefined, will be culture invariant. Can I? What's culture info with invariant? I'm not sure as well. Whatever. Let's make it like this. And the thing that I return will be this. Culture. Now let's Google up some cultures. Culture info list C#. Doesn't matter. Right. You can basically do all cultures to get the list of all cultures. Anyways, let's see Lithuania. LT, okay. Euro. So what is the most Euro country? I'd say France, Germany. Maybe Germany. And undefined. Invariant. Okay. So empty string? Is that it? That's cool. Because based on this, it seems it's empty string. Okay. So we convert money into this. So let's print it. We have this is invariant. Let's see what happens. Maybe. Okay, I was expecting amount to be actually printed as currency. We need to then use the currency thingy. So let's put amount in here. Currency with 2 symbols and quotation mark and environment, culture, current, no, current, crap, I don't remember. How do you set culture? here I can definitely not do that. Current culture info. Globalization. No, okay, I won't guess. Let's Google. Set culture and set different culture for formatting. C#. Whatever. Okay, here we go. It has that thing. Nice. So string format is what we need. Culture info. Let's take culture. Let's take currency. Like this. Wait. That format, culture, number. Okay. Why was it 0 points? Oh, okay. It makes sense. So we want 2. And we want the culture. And that's it. Okay, looks good. Let's try it. Nothing happened. That's correct. The amount. But it doesn't change anything. Culture. Because currency, we want currency. How do I specify that it's currency in this format? Zero as currency. Currency. Format C2. It won't work with C2 because it needs the first number is the index of parameter. But maybe like this. No. Okay. Stack Overflow will help. C# print currency, different formats. Okay. Like this. From the third try we made it. Amount. C2. culture return. Let's see, bracket missing. And what's the culture? Yeah, those seem to be correct cultures. Why is there a question mark? For what cultures? Is there a question mark for Euro? And for Euro we had that. Okay, let's just print whatever that thing was to see if we're doing something wrong. Mount. Right. Okay, we'll see. But I took it from a list of cultures that I found here, that is by the standard that is in .NET. This shouldn't be relevant. What actually gets printed? Which culture? Yeah. Oh, you mean as formatting? That makes sense. That is correct. I'm stupid. Sorry for that. Okay. Environment encoding, or was it environment current coding set? Oh god, I don't remember. Default. Oh, come on. Console output encoding. Okay, thanks. Okay, here we go. Thanks a lot. Yes. It's actually a bit annoying because I taught you that stuff and I already forgot. Well, it just proves that if you don't practice it, you won't remember. Okay, so let's test it for different currencies. Let's have euro. Let's have invariant. Right. Dollar. Okay, you looked up. Dollars. Dollar. This is bad. I need to print the string. Okay. Then we have what's LT? Right. I wonder what LT will print. It should print euro. And unknown. Undefined we already have. And that's all. Yeah, that's all. The string. Okay. It doesn't the string automatically because in order for this call to string, it needs to be an object. And if you hover over this, you see if you hover over this, you see what it calls. It calls decimal overload. It doesn't call money. Like there is no overload for write line which takes money. And so it takes decimal because it implicitly can convert money to decimal. Yeah. All right, let's see. I'm interested. Um, euro as decimal. Okay, for dollars and euros, it didn't do anything. Also for undefined, it didn't do anything. I did, I think. I didn't, okay. What's... Oh, come on. Are you serious? Are you serious? United States? Okay. Are you serious? There... Come on. Okay, here we go. That's funny. And the undefined. It's funny that for LT it doesn't find anything. That's pretty funny, I think. I wouldn't expect that. We're trying to print currencies in different format, and this is an illustration of overloading operators. Well, undefined. If it's undefined, I want to have culture invariant, but doesn't. Okay, let's just print it. See what it prints. It's so weird. Okay, that's fine. Euros. 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 Okay, that I don't understand. Undefined clearly has this one, but it didn't print that one. For For LTU, it didn't have any as well. Let's put the breakpoint here. Right. Okay. Well, I said it myself that you have to call this. But for this one, well, of course, because it's a decimal. So of course it doesn't call those. It's a decimal. Wow. How easy to miss. How... Oh, God. Okay. Run again. Here we go. So now we have what we expected. Um, when it doesn't know what culture it is, it prints this symbol. For those who don't know, who missed, this sun symbol is for unknown culture currency. If currency, well, great, they got it right. It's not litas, it's euro. That's great. So for Lithuania, it's euro. For other countries, it's euro. For USA, it's dollar. So now we actually have useful, meaningful value object, money, and it has normal, decent logic. Based on its currency, it prints culture-specific currency. To C2, sure, but doesn't matter much. It will print just 2 digits. All right, that's cool. So now currency has more meaning than just just flag for currency. It's logic. Okay. Next. Comparison. We already saw if you compare bananas to apples. You can do that. It compares their weight. Oh, what did I press? So in this demo, you see we just applied comparison operator for them, and it compares. And equality requires the opposite, and the opposite is just inversion of equality. In this case, it's just comparing the names of the person. So quite simple. Yeah, that's all I wanted to show, and I think it was a good lesson. We found, like, we figured out how to print those currencies. We figured out how implicit and explicit cast works. Cool stuff. Do you have any questions? Now, okay, good. Not really, not everything clear, no. um, um, if you have any question, please ask. Now about the project, the group project, I'll try to organize a meeting sometime next week. And the thing about project, I was actually contacted by by, let me get my phone and let me quote the thing. I was contacted by National Native American AIDS Prevention Center, and they might want an app for uh, health resource location and secure chatting. Um, I don't know any more requirements, and what I'm planning to do is to get in touch with the guy, have a call, record it, and try to gather what do they actually want, because now it's just guessing. But it sounds really cool, I think. And I also think, based on the experiment, the last homework that I tried to put people together in groups, I'm a bit afraid that the same might happen in working on a group project. So I will make one big group instead of many small groups, just to reduce the possibility of failing to deliver. Because I'm somewhat sure that overall people will deliver. There can still be teams, like micro teams. Some teams focused on, let's say, making a chat application, other teams on health resource location, and the third team on unifying everything, making a front face, and so on. Uh, so yeah, uh, sounds good, and I really hope that he will reach out. It's a bit of a delay in responses, so it makes it difficult. Um, Hierarchy. I agree. Uh, there will be um, there will be those mentors who will help you, but I'm not sure if it should be an internal team member, someone like a team lead, and I think there should be a team lead. Uh, but if there isn't anyone fit for that role, then a mentor will take that role, just as someone who can put a direction of some sort. But anyways, you'll do pull requests, and then pull requests, we'll see how it's going. So yeah, that would be cool to do that project. I think we can do it. It doesn't sound crazy big. It sounds something that can be very scalable, that we can make something very small. But at the same time, if we make something small fast, we can make something bigger in longer period of time in the amount that is this bootcamp. Also, um, next Wednesday, last lesson for this chapter. And next chapter will be testing. Testing will have homework. And I think, well, I don't know, but I think if you do the project and if there will be also homework, I think that there shouldn't be homework for those who are doing a project, because I don't see you guys doing both things simultaneously. Um, about tests for tests, maybe, but it's called corruption tests or anti-corruption. I don't remember the name. Basically, tests that takes your code, changes something in the code, and if your test passes, even if the logic that the tests remains change it is changed, then the test should fail, obviously. So that's called corruption tests or something like that. So maybe I'll try those. I never wrote those, but it would be a nice experience, a nice opportunity of writing those. So yeah, next chapter, TDD, you'll write tests, that's great. 100% used all the time in professional environments. Yeah, that's it for this lesson. Thank you all for watching and see you on Wednesday. Bye bye.